Yeah, I forgot.
It seems like it should be harder than that.
What is exponential form? I forget.
Exponential form is when you write something as an exponential, like something raised to a power.
Okay.
Like an exponent.
Alright, let's look at 17. In 17, they're going to be nice to us and give us multiple choice here. But I don't want to look at those choices. Let's just look at what we have here, and then see what we can do with it, and then see which one matches our answer. Alright, so I've got log base 5 of the 5th root of 2x plus 5 over 2x squared.
Now, would we multiply the top one out? Or put it to the 5th power so that we get rid of that 5th root?
No.
No.
You can only arbitrarily raise stuff to a power when you have an equation, and you can do both sides. Since this is just an expression, that if I just raise that to the 5th power, that would make it something different. Okay, so I have to take what they've given me here. I can't change the powers. What jumps out to you here first? Division, right? That would jump out to me first. So if it's division, then we want to split this into two things that are subtracted. Okay? And I'm just going to look at the numerator and the denominator. So I would have log base 5 of the numerator, so the 5th root of 2x plus 5, minus log base 5 of the denominator.
Well, I'm guessing since it's a 5th root, it's going to be 1/5.
Where does that 1/5 come from?
Because the 5th root is what times the 5th power would equal 2x plus 5, I guess.
Okay, so something you guys may not know that is true is that the nth root of something, so if we have the 5th root or the 4th root, the square root, whatever, that's the same as the 1 over n power. So you guys may not have learned that before, but that is true. So the 5th root of something is the same as that stuff raised to the 1/5 power.
Say that again.
The 5th root of that stuff is the same as all that stuff raised to the 1/5 power. Same thing. Okay? So in your calculator, if you want to be fancy, then instead of using the square root, you can just start raising stuff to the 1/2 power.
1/5.
Well, if the square root would be the 1/2 power. The 5th root is the 1/5 power. If it was the cube root, it would be the 1/3 power. So this log base 5, if I want to get rid of that 5th root, I can change that to 2x plus 5 to the 1/5 power.
Well, that can't be changed anymore because we can't separate those. Well, actually, no, the coefficient. We have to turn our to.
I want to do that so that I can bring that power down in front as a coefficient. Now, what about the second part?
That can be split up. You have your coefficient in there and you have 2x.
The second part can be split up because I've got multiplication. Okay, so how would I split up the second part?
Log base of.
Add them.
Okay, I want to add them.
Yeah.
Okay, but since it's subtracted, I want to put them added in parentheses.
Now, wouldn't we turn the x squared into plus 2 log base of 5x?
Yes. Okay, now what can I do here?
Put your leading coefficients in front of both of them.
The last thing I want to do here is break down those powers and make them coefficients. So I I have 1/5 times log base 5, 2x plus 5. Okay, now since I've got this part that's added, I've got that in parentheses, I need to subtract the whole thing. Okay, so I want to distribute that minus sign. Make both of them minus. So I have minus log base 5 of 2, and then minus, okay, from that x squared, the 2 can come down in front and become 2 log base 5 of x.
Oh, so what you did there is you distributed the negative.
Okay, yeah, because the whole thing is subtracted, so I need to subtract them individually.
I was looking at my math on how they didn't have parentheses. That makes sense, though. So if, say that was somehow came out to be a log base of 5, 2 to with a negative log base of 5 to x, or x squared, you would actually make that positive when you distributed the negative.
Yes.
I'm not sure that can physically happen, but if it did happen, that...
Well, if it was 2 over x squared, then that would happen.
Okay.
Okay, so that's our answer. And that's as much as I can do with that. Now I just need to figure out which one matches that. It looks like choice. Oh, we don't have any letters here. It looks like okay. Now we can also go the opposite way, and instead of splitting stuff apart, you can actually put it all back together again into one expression. Okay, so let's look at 18 and let's see if we can go the opposite direction. Okay.
Well,
so let's look at this here. I've got 2 log base 8 of x plus 5 log base 8 of z.
Well, we need to take our leading coefficients and turn them into exponents.
Okay, so if bringing the coefficients down was the last thing I did before, it's the first thing I want to do when I'm going backwards. The first thing you want to do is bring up those coefficients and make them powers. So I'm going to have log base 8 of x squared plus log base 8 of z to the 5th.
Now that they're added, we need to multiply them against each other.
Okay, now I've got 2 logs that are added. So if I want to put them back together again in 1, then they need to be
Log base of 8 x squared times z to the 5th power.
Okay, so then I'm going to take that stuff that's added, and combine it into one log, and make them multiplied. Now it says for me to write a single logarithm. I have a single logarithm, so we are done. Alright, you guys got 18. See what you can do with 19.
Shouldn't be. It really is quite simple. We're just overcomplicating it. Oh, yeah.
I'm glad you think so, 'cause I think this is the hardest thing in the whole entire day.
I can't get it.
Me either. Not
I
even.
can't find it, I can't find it either.
Just like it. Aha! Okay. No. Okay, back to 19. You.
Mm-hmm.
Let's do our coefficient first. What? X plus 7 squared. And our family is right after that. Not sure how many right after that. There's 5 here.
Mm-hmm.
So it's ln x plus 7 squared. And then minus ln.
Okay, what do we think we want to do with number 19?
Convert it to division.
Convert it to division, and I also have two coefficients that I want to make into exponents.
So that x plus 6, that's 1.
That's the numerator. To the fourth power.
Oh yeah, to the 4th power.
Okay, so first thing I want to do is bring up my coefficients and make them powers. I've got ln of x plus 6 all raised to the 4th power minus the ln of x to the 3rd power. Doesn't really matter if you put that in parentheses or not. There's not a good rule about that. Okay, then I want to convert it to, since it's subtracted, I want to convert it to division. So the x plus 6 to the 4th becomes my numerator. X to the 3rd becomes my
Denominator.
denominator. And that's it.
Mine did not require the parentheses outside of it.
No, I don't think it would. It will require the parentheses around the x plus 6.
Right.
Let me see.
Is it because I didn't put the
Yes, you've got to put the ln in front of it. That's part of the expression.
Can you just stay there for just a really quick second?
Mm-hmm.
Okay, thank you.
Okay, let's go back to 14 and 15 and see if we can sort out number 14 and 15.
Just a second.
Now the problem here is that they've got this b here, and I don't know what b is. So what can I do here if I don't know what b is?
Let's see, log base of b equals not 27. So we don't know where our base is, basically.
We don't know what our base is. Now the trick here is that I can do this problem without knowing what the base is by using those rules. So I want to think about what rules can I use here.
Power rule. Is that what it is? As soon as your finger decides it wants to draw.
As soon as it decides it wants to draw, yes. It always wants to draw on the wrong page is the problem. It doesn't want to draw on the page that I want to draw on. Okay, so they give me two things. They give me log base b of 3 and log base b of 9. I want to use log base b of 27. Now there's actually two ways I could do this. Okay? What I want to do is I want to say, how can I think about 27 in terms of what they give me, which is 3 and 9?
They're multiplied.
They're multiplied, right?
So could you just take 1.9099 and 2.199 and multiply them together?
Well, I don't want to multiply them.
Would
Let's
you
think about it.
square them?
27 is 3 times 9. But with logarithms, two things that are multiplied,
They're actually added.
they're actually added.
Ah.
Okay? And this is what people used to do to multiply big numbers before we had calculators. So you'd have a table of logarithms, and you'd look up the logarithm of two numbers and then add them. Because it's easier to add big numbers than it is to multiply them. Okay? I mean, if you guys are familiar with slide rules too, slide rules work on this principle. That it's easier to add big numbers than to multiply them. Okay, so 27 I can split into 3 times 9, but with logarithms I end up with the log of 3 plus the log of 9. So I just want to add these two numbers together. Okay? So whatever those are equal to, if I add them together, 6, 9, 2,
So log base of b of 27 is equal to 3.296.
yes. Based on the information they gave me. Okay? Still don't know what b is, but based on what they gave me, that's what it's equal to. Now if you got 14, go ahead and look at 15 and see what you can do with 15.
I'm still at 19. So like precious. Oh.
Now what's the problem with the next one?
I'll tell you once I get there.
I have no idea.
They give me log base a of 2 and log base a of 5. And they want me to find log base a of 8. Now what's the problem here?
Why do they have squiggly equals? Why don't they equal out? What's it say?
Because it's approximate.
It just means that means approximately equal to. It means it's a number they rounded. So you would use the squiggly equals, like if you wanted to tell someone that that's not an exact.
I know what they're for. I just didn't know why they put them in the problem. Because I figured they could make whatever number they want. So they would.
Well, probably. Well, no, they would have actually like when they read the problem, they would have picked some number for a and used a real number for a, so that these are actually
Right.
so that it actually does work if you know what a is. They just want us to figure it out without knowing what a is. Okay, what's the problem here?
5 and 2 don't equal
Yeah,
8
5 and 2 don't work out to 8. Okay? Now the thing is, it says use one or both of these.
Well,
If it says use one or both, it means I might have to use both, or I could just use one of them.
2 is a product of 8.
So let's just use the 2, because I don't think the 5 is going to work. Okay?
So could
some of you guys may have to use the 5, some of you guys may have to use the 2. I don't think anybody's going to use both of them.
So could you take
Now what is 8 in terms of 2? Well, it's 2 times 2 times 2, right?
that's 2 to the third power. becomes 3 log base of A 2.
The 3 becomes your coefficient. So what do I need to do with that number that they gave me for log base A of 2? I need to multiply it by 3. So I take my 0.301, which is what they gave me for log base A of 2, and I want to multiply it by 3. So I get 0.903. That would be my answer.
I've got a really big number, log A is 323.
That 323 is 7 to the 3rd power. Do you have a 7 in yours? You got the 7 too? Whatever number they give you is going to be something to the 3rd power where it's one of the ones they give you. Okay, so those problems, sometimes they look tricky. You just have to know what the trick is. Okay, now let's change gears a little bit here and let's look at some applications. Now, some of these applications are pretty easy, like number 20, where they just give you an equation, and you just have to plug in some value for x. So a lot of these don't get intimidated by them because you just plug in numbers here. So on this one, it gives me an equation for the expected lifespan. Logarithmic functions are used a lot for things that are increasing in a rate that's slowing down. So like if you get a curve that kind of flattens off at the top, that's what the logarithmic graph looks like. So something like population, where the population kind of hits a saturation point, I guess, they would use a logarithmic function to model it. Okay, or the lifespan, because our lifespans increase to a certain point, but it can't keep increasing forever. So if you get something that kind of flattens at the top. Okay, what does this model estimate the lifespan to be for people born in 1951?
First you have to find out, you'd have to subtract that from...
It says X is the number of years from 1906. So I'd subtract 1951 minus 1906.
Right.
Give me 45. And then I just want to plug in 45 for X.
Right.
Okay, that's all you have to do.
And just plug it into your calculator.
Plug it in the calculator.
Plug it in, plug it in.
Okay, and since it says ln, you want to use that ln button.
Now when you hit the ln button, are you just simply doing ln of the year, or are you doing ln of everything after that?
Just the ln of the year. Let me find my
The years
They were born in 1972.
minus 1907.
Mm-hmm.
Okay, that's 65 years.
So that's what you're going to put in. First you have to put in 12.692 and hit the ln button.
Okay, so yeah, you want to close this parentheses after your 45.
You already hit it.
In this question, if it's close to the year, it really is the previous year. It's not the year after.
It just says round to the nearest year as
Put in
needed. So yeah, when they say as needed, they mean just follow the rules for rounding.
Okay.
Don't always round up or down.
Plus
Okay, so 6.5669 would round up to 66 years, and that would be my answer.
17.226, and then ln 65 for 6. So it's going to be 85 years.
Number 11, write the an exponential form of the equation.
A, the base, what, we start at 3, or?
What's an
A
Yeah.
to the 13x power equals A.
Oh. Yeah.
Hey, can you show us what we did wrong here on the calculator?
What did we do wrong?
We got the ln in the wrong place. The ln should be after the first number, not the second one.
Oh, okay.
So we do that.
Shoot.
Times
The
2,
upper throw button.
then ln, 65.
On this one I think you can go backwards, so you gotta take the delta and
17.
put the ln.
Six.
Just like multiple powers. Just a K ln and then times.
Thank you. I don't know.
Push it.
So why is it if it's certain why I can't back to find everything answer? And so yeah, that's what I needed.
Push it.
Right, that's the hardest part.
Okay, it also is same on number 21. Okay, a lot of these, 22, you're just plugging in a number. 23, you're just plugging in a number. Okay, some of these are with the interest problems where it starts to talk about doubling time. On number 24. The doubling time is a big application of the log or the ln function.